By now, you would have seen the release 1.203, and there are a couple of absolute barnstorming headliners in this release, like there are always, right? But particularly in 203, there's a couple of things, and one of them is indeed the query variable. Now, today, I'm going to take you on a much more in-depth tour through the query variable, show you some of the different uses for it, and give you a little bit of behind the scenes into it. Now, query variable, it's not necessarily obvious in the name, but query variable is all about selections. Now, selections in parametric CAD are kind of fundamental. In fact, anytime you open up a feature in Onshape here, you see this blue box, and the blue box refers to a selection, right? So it's asking for entities to chamfer here, entities to fillet here. Over here in a Boolean, it's looking for tools, or maybe tools and targets. Point is that selections are absolutely fundamental to the success of parametric modeling, and the success is based on robust regeneration and things happening downstream that you expect. So the intent that you put into your selections is going to be reflected and successfully regenerated as you go downstream. That is the plan. Now, the query variable is going to make that a whole lot easier, a whole lot more powerful, flexible, dare I say fun, but it's going to fundamentally change the way, well, there's the fun in fundamental, right? So it's going to fundamentally change the way you approach parametric modeling with Onshape. And for that reason, it's extremely exciting for those of us involved with it. Now, I'm going to go into it for these. I've got 5 sort of different demonstrations, so it might take a while. So sit back, grab a coffee or whatever, and follow me along with this. So I'll just show you what a query variable looks like in terms of its menu. You ask for a name, you can give a description if you like, and then there's a lot of different options for the selection type that you're going to use to create the variable. Now, it's a variable, just like any other variable that you can do. In fact, it is a variable. However, value it takes is a query. Right? So it's kind of abstract in that way, but you'll see it makes a lot of sense as we go into it. And there's a lot of ways that you can construct the query, either by just purely selecting things, looking for the ownership created by or owned by, and then sort of feature types like pockets, protrusions, holes, fillets, faces, those sorts of things, which you're probably already familiar with when you can do a create selection. Now, this just sort of gives a superpower to it in that it's parametric, it's feature-based, it can be used by other things just as you can use variables in other ways. So, armed with that knowledge, let's delve in and have a look at how you can use them for examples like the one I've got in front of me. Right, so there's a few ways that I have used it in this demonstration. And if I roll back to the point here and explain a little bit about how things like this get made. I've made a few of these in my time. And one very good way of constructing them is to use a multi-part technique in lots of Booleans. So I'm going to hide the rim on the outside for a second and show you what I mean. The dark blue thing is sort of an uncut disk, and I'm going to cut out a series of blocks which will then form the spokes, and you can see the blue spokes that are going to be cut out in there. So you create your base geometry and you create your pattern of these spokes. This is the way that it's done time and time again in this kind of industry. So you get to this point, and then you would use a Boolean feature and say, well, let's subtract from the blue blank disk, and then let's choose the tools to subtract out of that. And you can see here, as I'm going around, it's making those subtractions as we go there. Now, that's all well and good, but what happens, in this case, I have a quite nicely configured model. I mean, I can configure this with number of spokes or number of the lug patterns that we have yet to cut. So if I change this to a 7-spoke, you'll notice that something kind of unexpectedly, bad has happened, right? I've got these parts which I were going to use in the cutout, but of course in the Boolean I hadn't chosen them. Right? How could I have known ahead of time that I would be having to select things that didn't really exist at the time? For that reason, and a big solution to this is to use a query variable instead of a manual selection. So if I go back to the 5 spokes, and I'll show you the query variable that I created, and I've named it tools to use because it's always a good idea to name variables, and then don't hold back with the length of them either, right? You've got a fair few characters to play with, so make it something that is understandable for people coming after you. And actually, this is a really important point. Just take a quick pause for a second here. One of the massive benefits of using query variables in your selections is that it's very much more readable when other people come to have a look at what you've done. Just like reading somebody else's code makes a lot of sense if variables are nicely named and there aren't sort of magic numbers in there. Everything is based on constants and variables which are named and clearly annotated throughout your code. Same goes for parametric modeling. And we're in this point right here. I've created this variable called tools to use, and I've used a selection type called created by. So what that is doing, so if I give a list of features, maybe the first enclose, which was this one here, the second enclose, which was this feature here, and then, this is a really key one, I've chosen the circular pattern, right, as the feature, and I want to then extract the body, or the face, or the edges, or the vertices created by these features. Now, in this case, I'm using the bodies. So I've now got a selection set containing the bodies that were created by these features. Now, nothing's happened to them yet. I'm going to use them now. So I'm going to do my Boolean again, and I'm going to use a subtract, and I'm going to use the blue as the subtract tool, the target. But in this case, for the tools, I'm going to hit this little eyeglass, magnifying glass here, which is the query variable icon. And you'll see here I've got a selection for tools to use. Now, if I use that, it just will evaluate the query and bring those bodies in for those tools. And just like magic, it's going to work like that. So I've got this feature here, and I can change that between 5 spokes and 7 spokes. And of course, I don't need to reselect anything, because the pattern was the thing that changed, right? The pattern was referring to the number of spokes as the variable, but the pattern was also the feature in here in the created by, looking for the bodies created by the pattern. That's an incredibly powerful and very, very easy thing to achieve, and very, very easy for other people following after you to understand. So let's continue down and see if there's more usage of the query variable. In fact, there is, and it's right down the bottom here. Right. So let's just skip ahead. And I've got a model where there's lots of sharp edges, and I'd like to knock all the sharp edges off with a chamfer. But I don't want to knock off the edges which are with concave. I don't want to touch those concave edges. I only want to look at the convex edges. These ones kind of here. And there's a few special edges in here which I'd like to keep as sharp, these 2 particular ones. All right? So, as you guessed, there's going to be a query variable that can do that for me. And I've got it right here. And you can see me previewing it. I've got all these sharp edges on the back there. All right. And if I have a look at the query variable, it is one where the selection type is this special thing all the way down the bottom here called edge convexity. So it's set up to do edge convexity of the entire body. So I've just picked the rim as the solid body for that. And it's going to look for convex, concave, smooth, or variable edges. And in this case, I want convex, of course. Now, this brings in the next really, really powerful thing with the query variable, is that you can stack and add additional queries to slightly modify them. So in the case here that I mentioned, I'd like to subtract, or I could add union or intersect as well. In this case, I'm going to subtract edges which matches the edge of the revolve feature that I used to create this cutout for the lug, right? So this is a conical lug. Seat is very typical for a racing wheel. And I'm going to choose that edge there, which was created by the revolve feature, and I'm going to match that. So it's going to pick all of them for the same revolve feature, which was patterned again, and it's going to subtract that from the original selection set. So at the end of the day there, we've got all of these sharp edges except for these two here, these two here, these two here, and these two here, which were created by that revolve feature. Now that is a powerful selection to hold because the next feature is going to be a chamfer feature, which I can then just input as before. I'm not going to select anything other than the query variable called, hash sharp, right? So that is the easy way. Now, the good thing is that if I change this to a 5 lug wheel design, when this updates, those sharp edges will be updated, even though there's quite significant topology changes and number of edges that I'm going to put into that selection set previously. On the back as well, I've got these pockets, and I had used a query variable again in there. But I think that as a first initial example shows you two very different but powerful uses of the query variable. And let's move on to the next one. So one of my favorite examples from this, when I start using query variable, I'm going to be able to retire a number of custom features that I had previously written and demonstrated. And that's sort of bittersweet to me, but let's move ahead, let's move on, let's use query variable as a native and more powerful way of achieving what my previous custom features had been doing. Right, so in this bearing, roller bearing example, it's highly configured. In fact, if I have a peek at the configuration panel here, you can see there's an extreme number, and I'm really glad I can collapse that now. You could collapse and expand tables and configurations for the last couple of releases now. We also have a configuration on the seals and whether the thing is fully packed or not. Fully packed kind of looks like this when you can squeeze in another ball. And the seals, there are 3 options. You can have no seals, you can have just the front seal, and you can have both seals, which is the sort of ZZ designation there. So let's go back to the no seals. And if I change between 6203, 6303 or 6403, just one of 2,000 examples in here, the number of entities does change quite a bit. So this is, again, a similar example to the wheel where a pattern or a number of features that are changing is going to substantially change the way that we would have done a Boolean operation in before. So let me roll back to here and show you some of the construction method. So here is a revolve feature which created this sort of ring, and what I'm doing here is I'm creating the cage, where the balls are contained in here between the races. So I've got, again, a multi-body or a multi-part studio, which is, this is a very, very nice way to do things because I can have a parametric feature like the number of in a pattern, the number of entities in a pattern is going to obviously be driven by the number of balls in the ball bearing. Right? So I've got that pattern, and I've got these sort of containments here, and what I'm going to do is try and create a query variable of the 2 features which create the shapes plus the circular pattern. Again, this is exactly the same before actually. I'm looking for the bodies created by these 3 features, and no matter how many there are in this configuration, I can just do a Boolean union them together like that, and now we've got a single part. Now, if I change the number of things in there by changing to a different bearing designation, no errors in the features, right? So this is a hallmark of a nice, robust parametric design, is that it's compliant to change, it's resilient to change, it's very robust, right? So that's exactly what we want here. So that was the first use of the query variable. I've got another one here, which is a very similar situation. Now I've got, if I have a look at the particular, I've got the balls for the ball bearings, and I've got the cage here, but I need to make a cutout. All right, so I'm going to do a query variable, which is defined again by, I'm looking at just getting the balls into the query variable. All right, so that's looking for the bodies created by this revolve and the pattern. Once I've got that, I can then do a Boolean subtract from the target. I'm just going to subtract that query variable and be left with, if I take I'll be left with sort of the cage in its sort of complete sense there. All right, so that's nearly all, but not all, right? So let's put that back. Let's get to the end here where I've got the race, the inner and the outer race. I've got the cage and I've got all the balls there. And again, if I change between the designations, you'll see that everything updates nicely. I can do fully packed. Maybe I'm going to add one seal to it. That one there. Right, so I want to finish this off by creating a single composite part. Right? I want to do that because I'm going to use this as sort of my parts library. I want to be able to insert a single entity, an inseparable entity of the bearing, into an assembly and have it appear as a single line item. It's an inseparable, it's a single SKU, right? So, that's what composite parts are really good for. Normally, you would just hit the composite part and say, well, let's just pick the entities, right? So let's pick we've got to pick the seal, the inner and outer races, the cage, and then let's pick all of these. And lucky I haven't picked one with many in there. It's going to take me a while otherwise. This is actually a problem. It can be quite laborious and you can miss a pick. And did I pick that or not? Yeah, I didn't. Yes, I did pick that. Yeah. Okay. So now that is all picked. We've got our single closed composite part. But what happens if I change to some other designation, like maybe both seals? Now, was that seal in the? No, the seal is not in the composite part. In fact. So now I have to go back and update this feature. What if I change the bearing to a 6303? If I look inside by hiding that seal, I see that two of them haven't been included in the composite part. So it's a real mess. Right? Basically, it's a real mess if I do it this way. Fortunately, we have a much better solution now, which is the query variable. And there's a query variable option called all solid bodies. So this is going to create a query to find me all of the solid bodies in this feature that are created by these features. So that's pretty simple, right? So you name it, composite all, or whatever you want to call it. Again, I'm going to look for all solid bodies. And then when I do the composite feature, instead of having to pick anything at all, I'm just going to say, let's put all composite all into one. Done, right? So now I have a single, there's no parts left over this time, and I can change to another bearing, no errors, no parts left over. Let's look at 6403 instead. Yes, again, no parts left over. If I hide in there, everything, it's a single part. So that is the huge benefit of the query variable in this case here. And that was one that I was commonly using custom features to do, this composite all, Boolean all those sorts of things. My next example, I won't spend so much time on this. I did do a kind of a detailed video of how I created this parametric wing. Again, it's fairly flexible between configurations here. I can change the number of ribs across the wing pretty easily. And if you have a look closely, and I sort of highlight and isolate this one, you'll see that there's some quite complicated sort of tap dancing with merging and cutting out from the different parts here. All of these rib caps, and if I highlight that one there, you can see this rib cap has to slot in between the two ribs in front of the spar, spar caps there. So being able to do this and have it update robustly and predictably with these parametric changes is the challenge, and it was all very well and good to set those challenges and meet them in the past, but now I'm going to be able to, again, throw away a few custom features and do this natively, and in fact, much easier than I ever did before. So I'm going to roll back and show you this. The interesting thing with this one is that I first created the custom feature pretty early on when these ribs were, you can see how they're kind of just interfering through everything. That's a single body right now, and I don't care about the cutouts yet, either on the nose and the tail, the leading and trailing edges, or the cutout for the spars. That's all going to come later, and that's why we're going to create this query variable now. And the query variable, kind of predictably before, this is one of my favorites, is the created by, including the things which created the pattern, like the thicken feature, which was the rib all the way at the beginning there, and then the pattern, creating all the bodies from it. Now, if I only wanted faces, I could have done that as well, but I want bodies in this case. Now, I'm going to use this same query variable a number of times, and actually I've named them this way. There's a Boolean, there's another Boolean, there's another Boolean, and I think there's even a fourth one somewhere where I use the query variable in various features. And that's all good. If I have a look at this first Boolean, I did a subtract using that query variable, and I subtracted from these front and rear spar caps. That's these two vertically sort of oriented thin rectangles here, and so I'm doing a Boolean subtract, and it's going to end up with these as now. There's going to be a slot in here. I have to do a few more cuts, but you can see here that this has already started the process of cutting things out the way that I need. All right, so that's the first use of it. I do it again down here, where I'm cutting, in this case, instead of using the ribs or the query variable for the ribs as the tool, I'm using this same query variable as the target. Kind of cool, right? So it's the same query variable, the same single selection, and into the targets, and the tools in this case are the leading and the trailing edges, which leaves me with a rib which is sort of a bit more up to date. Now I've got the head and the tail cut off it. And you see how I can go through this a little bit further. I've got another one here where I'm starting to this is where now I do another Boolean to cut out from the target being the ribs again. I'm going to cut out the top and the bottom spar, and that actually really leaves me with essentially the finished rib here. So as always, I can just go to the end, and I think I probably did this before, but maybe I'll just try the 8 rib version, and there's going to be no errors, whatever the number of ribs that I choose, and the configuration, which puts a little bit more angle. It is actually not a right angle on that. You can see here it's a little bit swept back. So these things aren't perpendicular anymore. Anyway, that doesn't matter because it's a robust parametric update, and that's again what the query variable is designed to do. Now, moving into a slightly more esoteric, but nonetheless very, very interesting use of query variables, and I've spent quite a bit of time on these first three. There's many of the selection types that I haven't covered yet, so I'm going to try and cover a few more of them in this example here, which is clearly aimed at something far less mechanical, much more sort of surfacing related. Right, so the first query variable I've done here is a very, very simple one, and the selection type is just called selection, which is a manual selection. I can just pick a face, pick an edge, pick a body, pick whatever as my selection type, as my selection, and I'm saved it as a thing called a face, as the name suggests. All right, so my next one then shows an interesting usage of query variables in that you can input to a query variable the result of the previous one. So here, follow me along here, follow with me, sorry. I'm using a loop chain connected type, and this needs a face as an input. And we just created a face here, remember? A face. So let's use it as the input. And it's going to create, you can see here, the yellow bit around here, it's going to create some loop edges. So now that is another query variable, right? So one query variable led to the next. All right. Now I'm going to use it. So one of the nice features you could do with this, just for example, is use an offset curve. Now an offset curve takes one or more curves on a face, edge curves, and offsets them some amount. So maybe we're going to go 1 millimeter in. And the input to this is just going to be the loop edges that we created a second ago. And you can see here now, if I adjust the size, the offset, we could also, this offset curve allows us to do the splitting operation as well. So now we have this, we could delete that face if we wanted to. We've created a nice little pocket opening, whatever in there. So that's exactly what I did with this feature earlier. And then let's go even further. So the next custom query variable, I don't need custom features anymore, I only need query variables. Look, still so new. All right, so I've got this new query variable, which is a new type for us today, which is an owned by. So I'm looking for what sort of entities, like faces, bodies, edges, vertices, that weren't created by, but are actually owned by. And so if I choose the surface body, which is the whole body, it's not just an individual face on the surface. Remember, surfaces is the body, like the part is the solid body, right? So anyway, surface body here, and I'm looking for all of the faces that were created by it. I don't need anything additional, I'll just use that. But I'm not done yet, I've got one more query that I want to show you. So now that I have all of the faces which are owned by this surface, I'm going to find the loop edges of that surface, of all those faces. So these are the various different ways of defining what those edges are called. In fact, we have a thing called highlight boundary edges. That's this red boundary edges. Some people call them naked edges. Some mathematicians and other people would call them laminar edges. There we are. That's what we're looking for. So the highlight boundary edges is the thing we were looking for, but now we have those edges safely tied up in a query variable. Perhaps we want to use them somehow. All right, so we've created this query for all of these edges on the outside. Now I will use them. I'm going to create a ruled surface, and the ruled surface takes edges, and you see it's put a little flange like that up around all of these edges, which are the sort of naked edges, highlight boundary edges, laminar edges, those things. And again, as you'd expect, I have not selected any edges. I have used the query variable called boundaries, which is from before, and I can adjust this feature as before, and it's all good. Now, an interesting demonstration of how robust this can be is that if I go back and delete one of the faces, maybe the face that we had created in here before, if I delete that, you'll see how this edge became a boundary edge, right? And the query for it came after. So of course, the usage of that query, which is the ruled surface, is going to take that into account. And the same with that face here, if I delete this one as well. So you see here how robust this can be when you use, and what I meant by saying it's going to fundamentally change the way you do parametric modeling in Onshape. Now, selections and selection sets are not new in CAD. In fact, selection sets have been around for forever, right? Pretty much ever in parametric CAD. So we're not claiming to have reinvented that. We are certainly doing it in a much more powerful, flexible and much easier way to do it than ever before. So that is that's the claim I'm making, and I'm sure you'll agree when you start using these things. Now, I have one final example and then a +1 at the end of this final example as well. So I'll just need to remind myself for that last +1. If you are a custom feature creator, you will enjoy what I'm about to say, which is you can create your own query variables from within your custom features. So I have created a custom feature which is very, very simple, and then I'll show you the code, the key part of it. So this custom feature is called myQueryVar, and it's just going to let me pick things that are going to go into the query variable. So I'm going to select this sketch entity, these vertices from a sketch, maybe this face, this entire surface, maybe the whole part as well. Let's use that to get surface 1 in there. Okay, and then here we're also going to use part 1, which is that solid block at the top there. Now, this has created a query variable that I want to use, and I'm going to use it in a kind of strange, but you'll see, very powerful way. I'm going to create a hole now, and the hole is, beside the point, and it's a 1/2 inch straight pipe tap hole. And I'm going to have to define 2 things for the selection. I need to show where the holes are going to go and what's the scope that the holes are going to go through. Why don't I just use my query variable? Remember that I created one before from my query variable, and it's called my stuff. Now, an interesting thing has happened, but I'll tell you how interesting it is after I do the next bit. The scope, I need a scope as well. So instead of picking manually, and again, when you pick manually, you run the risk of, well, what if something changes in the future and the number of bodies has changed? I'm going to have to repick things. So to avoid that, I'm going to use a query variable. I'm going to use the same query variable? What do you mean? This thing had edges and vertices and faces and whatever. So, it worked. Now, the secret and magic of this is that we automatically filter out things that aren't relevant for the selection. So even if your query variable has multiple different selection types in it, like faces and vertexes and edges and vertices and faces and solids and surfaces and whatever, it doesn't matter, because we'll filter them out and only use the appropriate ones in here. And of course, if I want to add one, I can. I've added the single pick of this vertex, and everything else is using the query variable. That's pretty powerful. Now, if I show you the custom feature, it's laughably simple in that I just collected things. You could collect this, the selections programmatically, however you want. That's what my note here is. Then this is the one-liner you need. Set query variable with the value of what that query is. That's all it takes. Oh, actually, one thing you need to do is you need to import this query variable.fs. And there you go. There's your training class in how to use query variables in custom features. And that is incredibly powerful, as you probably would already be nodding your head in agreeing with. Now, the one final thing at the end here, if I go back to the ball bearing, and I go back to the default, there's a really interesting, intriguing thing here, is that I could remember this query variable composite all, and it was for all solid bodies. I'm going to take that all the way back to the top of the tree here, before anything existed, right? This is no, if I roll back the model to this point here, there's nothing in the model. There's actually just 3 data planes, right, and an origin. I think that's all. Yep, that's all there is. So how does this work? If I roll to the end, no errors, we still have our single composite part at the end. How did that work? Indeed. Now, there's an option, if we look back in here, saying evaluate on use. Now, this is not on by default, but what it means is that where you can define this anytime you like, but we're only going to evaluate it when you use it. And in the case here, I only used it 41 features later down the bottom. So it evaluated what all the solid bodies were just as I tried to use it in this composite part here. Now, it's maybe sounding a little obscure, and you're going to have to try this out for yourself as to when that might be appropriate. But the option is there, and as I said before, it's not the default. The default is to basically evaluate it as soon as you create the variable. That's the default. But throughout all of these examples, there's going to be a lot of experimentation and joy and discovery when you find out how you personally are going to be best suited in using these query variables. This is just pretty much feels like scratching the surface still at this point. So I'm really, really looking forward to how you all are going to make use of this new thing, query variable in Onshape.